Okay, welcome back. So just carrying on with our next topic. But before we do that, I want to go through a homework exercise that you may have completed by now, but if not, you maybe want to copy some of this down. So the question was, this was from exercise 6.2, what is the distance between Montevideo at 35 degrees south, 56 degrees west, and Canberra, 35 degrees south, 149 degrees east, along the parallel of latitude? Now, remember that directions are always written as latitude, then longitude. So that allows us to work out what's the same and what's different here. Also, those words, along the parallel of latitude, tells you that the latitude of those two places are the same. So that means we've got a difference in our longitude, and we need to use the formula for that, which was distance for 1 degree of difference in longitude is approximately 111.2 cos theta kilometers. And remember, the theta is the latitude value. And in this case, that's 35 degrees south. So substitute that in, then work out the difference in the longitude. Now, in this case, our longitudes, one is west and one is east. So just like when we had one north and one south for latitude, we need to actually add them together because they're in different directions. So we've got 56 degrees west to go. We need to go all the way back to 0 and then go another 149 degrees in the easterly direction. So altogether, we've got 205 degrees difference in longitude. Now, remember I said last lesson, sometimes it's quicker to go the other way. This is one of those times. So it's shorter to go the opposite way around the Earth's surface. And if we think about the Earth's surface being a sphere or a globe, there's 360 degrees all the way around. So if we take that 205 away from 360, that will tell us how many degrees difference in the longitude there is if we turned around and went the other way. So that's what we should be using here. It's always going to want the shortest direction, even if it doesn't say that. So now that we've got that, that's what we're going to put into our original formula. So the distance for 155 degrees difference of longitude is 155 degrees times 111.2 cos 35 degrees kilometers, which is approximately 14,119 kilometers. So that question contains a couple of tricky things in there. So if there's any problems with that, please come and see me. All right, well, today's topic is days and their lengths. And again, we've got some formulas you need to learn. So for a place where the latitude is less than 66.5 degrees, these are the formulas you use. Now, we're not going to be finding length of days for places that don't fall into this category. So that's all you need to worry about. First of all, determine if the latitude is within that range, and if it is, use these formulas. So the daylight minutes of the shortest day is found by this formula, 8 times cos -1. Remember, that's just the inverse cos of 0.4338 times tan theta. And the daylight minutes of the longest day is the same formula, but you're going to take that away from 1440. And both of the answers that you get for this are in minutes of those days. Now, the other thing you need to take into account, which it doesn't say here, is to both of our answers for those, we need to add an extra 10 minutes. This takes into account extra things like atmospheric conditions as well as the curvature of the Earth, because that is going to alter it slightly. So if you just remember, find your answer using the formulas, add 10 minutes onto each one, you'll be fine. So let's have a go at doing one. So what are the lengths of the shortest and longest days in Brisbane at latitude of 27 degrees south? Now you can see that 27 degrees south meets our requirements of being less than 66.5 degrees. So because it does, we can use these formulas. So the shortest day is found. Now the first thing, all that's been done is the formula has been written. Theta is latitude, so we can substitute that in instead. So we know our latitude. Our latitude is there and it tells us in the question. So we're going to substitute that into the formula, and that's going to tell us how long the shortest day minutes are there. 8 times cos -1, 0.4338 times tan 27 degrees minutes. So once that's substituted in and we put all of that into our calculator, that's going to tell us that the shortest day at that latitude is 618 minutes. Don't forget to add the extra 10 minutes for the curvature, etc. that we talked about before. So once we've done that, we have what's called corrected time, and that is equal to 628 minutes. Now, 628 minutes is not a very useful measurement. So the first thing we want to do is convert that to hours. So divide that by 60 to work out how many hours. So that's going to give us 10.47 hours. And the 0.47, also not very useful. Remember, that is not 47 minutes because hours are divided into 60, not 100. So you need to take that decimal off and you need to do something like this, 0.47 times 60 and convert it to minutes. So hopefully that makes sense to you. Just cut the decimal off, multiply it by 60, convert it to minutes. So that is the answer for the shortest day. Now the longest day, we've already worked out all of that, so we don't have to work it out again. We can just use the formula. Now the second part of that formula was exactly the same as the first one. We're just taking the answer away from 1440. So if we take that 618 away from that, that's going to tell us there's 822 minutes. Add the 10-minute correction as before, convert it to hours and minutes. Exactly the same as before. So once you know the two formulas, using them is actually quite simple. So if you have any problems with that, please let me know. Now, we're going to talk about one last new concept today, and that is solar noon. So solar noon is when the sun is at the highest point in the sky. This is not always at 12 o'clock because sometimes our days are really short. Like in winter, the sun rises later and it sets earlier. And in summer, it gets up really early and it sets quite late. So it's not always at 12 o'clock, which a lot of people assume, but it is always exactly halfway between sunrise and sunset, no matter how many hours the sun is up for. So because we know this, we can use something called half days, or literally a whole day divided into two, to find something called solar noon. So when is the sun at the highest point is what it's asking. So let's look at this one. So on the 3rd of April, the sun rises at 5:59 a.m. in Brisbane and the day is 11 hours and 46 minutes in length. At what times are solar noon and sunset? So we need to calculate those half days, or literally at what point is it halfway along. So you're going to literally divide that 11 hours and 46 minutes by 2, divide it by 2 or multiply it by a half. Remember, that's exactly the same thing. So, or divide by 2. Now, 11 hours and 46 minutes is not going to give us something nice, because we're going to have 5.5 hours plus half of 46 minutes, which is going to take us into more than that. So what I have done here, this step, is literally 60 minutes plus the 46 minutes that are here. I've taken 1 hour off here and I've added it here, plus 1 hour here, turned it into minutes. You do not have to do that, but it may help you to do that. And once you've done that, it actually makes dividing it really easy. So 10 hours and 106 minutes divided by 2 gives us 5 hours and 53 minutes. So that tells us that solar noon is 5 hours and 53 minutes after sunrise, which we were told was 5:59 a.m. So once you know that, you can add them together to find out what time that is. So that would be at 11:52 a.m. and you can see the answer here. If there's any part of that you can't follow, please ask me and I will go through it with you in class. Now sunset, we can do one of two things. We can take that solar noon time that we found and add the rest of the half day on, or we can just take our sunset time and add the total length of the day on, which is what I've done here. I do recommend you do it that way because if you've made a mistake with solar noon, it's not going to affect your sunset time answer in any way. So it's literally sunrise time plus length of the day, work out that time. And that's got to 5:45 p.m. So there's some questions there for you to do. Exercise 6.3, questions 2 to 6. If you have any problems with any of that, please see me in class.